Alright, so time for a little intermission. I had already recorded the rest of the seaweed part, but we are going to be using a little bit of Vex in there. I thought maybe it would be good to do a very short primer of the very basics of Vex. We're going to get more into Vex later, but at least so you maybe can understand a little bit more what's going on. Alright, so Vex is just a way of writing in code, which you can also do in VOPs. So if you, let's make a grid. So if you make a VOP, you can actually type snippet in here, and snippet will allow you to write code. And if you, instead of making a VOP, just type attribute wrangle, so that's where you can type the code. Essentially, if you dive inside of there, that's actually what's happening. So it just has a VOP inside with a snippet. But the wrangle will just allow you to sort of type stuff yourself. So Vex, I know it might be a little bit intimidating to a lot of you. It's actually not that bad, it's just the basic stuff. So just thought do a little primer on just some basics. So Vex is essentially just writing out in code what you could also do in VOPs. So let's make an attribute wrangle, and you can, again, like same as in VOPs, you can set it to run on detail primitives, point vertices, or numbers. So similar to what you would do in VOPs. And it's just faster to sort of put stuff in a wrangle sometimes than it is to declare it inside of VOPs. Let's say I want to set an attribute called cheese. I could say f@cheese equals 1. And if I go in my spreadsheet, you see that that there will be a float attribute called cheese. If I were to type i@cheese, it would be an integer. If I were to type v@cheese, it would be a vector. So you can just declare variables like this. I could also type s@cheese equals brie. So then it would be a string. So just easy to declare variables like that. So I could also, for example, say that f@pscale equals random based on the point number. So that's what we did in the VOPs as well. But you can see this is just faster than putting a random node, then putting the point number in, then making a byte export and say that it should go to pscale. It's just faster to do it in a wrangle like this. So then I could say that I want to, all right, so let's track back a little bit. So right now I'm doing writing this out as an attribute. What you could also do is sort of only use this inside of the wrangle. So so like similar to where when we were working inside of VOPs, we were also generating certain stuff that we weren't really exporting. So if you want to do that, you would type float pscale, or you could type vector, or you could type string, and then a name, and then it would just only use it inside of the wrangle. And then I can use other functions like pscale equals fit01. So that would mean I want to fit, just like the fit node. What do I want to fit? I want to fit pscale, and I want to fit it maybe from 0.5 to 1.5. And then I want to say @pscale equals, so sorry, I want to type f@pscale, but by default it will become a float, but you kind of wanted to, well, be specific about it, is equals pscale. Oh, and it needs to be fit01. And then you can see I fitted the range. So I could also, you could create sliders. So for example, I could create a slider called float min equals, and then if you type chf, that would mean channel float, and type min. So now this will make a channel called min, and if I then press this button, you can see I get a slider. Let's also make one for max. Type float max, and then call the slider max as well, and then press the thing again. You can do it like that, and then instead of typing values in here, you could say min and max. And again, if these were attributes, you would type an at in front of them. So now we can control this with a slider. So it's Vex is just a way to sort of do this type of stuff with just code instead of doing it with nodes. And a lot of times it's just faster. So let's do another attribute wrangle just to show some stuff. Like I could say that at p.y plus equals channel f. So just create a slider. So if I then do this, I can add to my y position based on this slider. So again, if I were to do this inside of a FOB, for example, the exact same thing, what I need to do is, you can see how much more work that would be. I would need to do vector to float on the position, float to vector on the position. These can be passed through. Then I need to put an add on the y, put that one in there, promote this, and then put it in position. And then we created the same thing that we did in here. So there's a lot of cases where it's just easier to use Vex. I'm not going to go that much more into Vex right now. I just wanted to give a brief overview of Vex, because in the other part of the seaweed stuff where we're going to use quaternions a little bit, I'm writing stuff in Vex. And it will be complicated enough as is. So I thought I'd give you a very brief primer of what Vex is. And we'll get more into Vex later, but just so you know what it is, and that it's sort of, for some stuff, it's just easier to use, and it's actually not that complicated once you know the syntax and stuff. Anyway, so there's just a quick intermission, and let's continue with the seaweed stuff.